Hi, everyone. One last comment about medians. Let's go to our president's data set here. We have the 45 presidents' ages, all right? The median position number was 23, which means that after we've sorted and deleted any header rows, okay, we want the 23rd youngest age. The 23rd youngest age on row 23 was Benjamin Harrison's age of 55 years. The median position number was 23. The median is 55 years. Notice there are 22 ages below the 55 years, and there are 22 ages above the 55 years. Remember, ties are okay. Ties are okay. But basically 22 ages above the 55 years, but ties are okay. All right, so 22 ages above the 55 years, 22 ages above the 55 years, but ties are okay. Okay. Next, our third measure of center or representativeness is called the mode. Actually, this is the answer to the fourth question I first asked, which was, how would you find a measure of center in 10 seconds? What's a very fast way of finding a central or representative measure? Let's go to the 100 data values, right? Well, how would you find a representative measure in 10 seconds? I'll give you a hint. Remember when we dealt with histograms? When we talked about modality, what were we referring to? We're referring to the idea of a hump, right, in the data. Frequent data, frequently occurring data, at least by class. Here we're being a bit more precise with our notion of mode. We want the most frequent value. All right. And it turns out the most frequent value, okay, actually, I don't even know what the most frequent value here is. I don't even know what the mode is for this data set, but I know that the mode for this data set, where we have the 5 data values here, okay, I know the mode here is going to be 100 points. The mode, specifically, again, the definition here is a bit more precise than what we had for histograms, but the mode is the most frequent data value, if any, in the data set. And we're using this term a bit differently from the notion of humps and histograms, which is a bit more fluid. So again, because 100 points was the most frequently occurring data value here, it appears twice, the mode is 100 points. Now, in that sense, 100 points may be the most representative data value in a sense, but is it appropriate as a measure of center? That's debatable. So although the mode is easy to find and it's an easy idea, there are several cons with it. So on the one hand, it's wonderful that the idea is so easy and we can usually find it quickly. Well, is it really so wonderful? Okay. By the way, you don't have to worry about the whole decimal, going 1 decimal point further issue. Don't worry about that for modes. Pros and cons of modes. Although it's often easy to find modes, and also we can use it for qualitative data, as we'll see below, there's some problems. They might be questionable as measures of centrality for quantitative data. Again, is 100 points really appropriate as a measure of center for this data set? In fact, the mode might actually be an extreme value, as in this example 1, all right? If anything, maybe the test was fairly easy and you just had a bunch of students scoring 100 points. In general, if you have a test that's fairly easy, you might have a bunch of students getting 100 points, and maybe the mode will be 100 points, even though a lot of the students don't get anywhere near 100 points. On the other hand, you could have a very hard physics exam where the mode is 0 points, although that might not be a very encouraging thing to tell the class. Okay, and it may not be appropriate as a measure of center necessarily. Or, you know, a mode may just be the result of coincidence. Hopefully not cheating, but maybe just the result of coincidence. So I do question the idea of the mode being a measure of center. Also, unlike with the mean or the median, there might not be a mode. Look at this data set. 2.41 and 3.62 and 7.25, there is no mode. There's a mean, there's a median, it's this guy, right? But there's no mode. On the other hand, this data set, 50 and 50 and 70 and 90 and 90, this has 2 modes. 50 points, oops, 50 points and 90 points. This data set is bimodal. We have the 50 points, and we have the 90 points. This data set is bimodal. So we're using the term bimodal a bit more precisely than we use it over here. Here, we had an example of a bimodal histogram or a bimodal distribution, but we mean that a bit more fluidly in the sense that there may not have been two particular values that appeared more frequently than others, but we had a range of values here and a range of values here that were more frequent than other ranges or classes of values. Okay, here we're very precise. 50 points and 90 points both appear more frequently than the 70 points. Okay. As I mentioned earlier, unlike for mean and median, the mode can be used for qualitative data, okay, such as presidential parties. Okay, so if you accept this as the frequency table for the parties of the presidents, okay, so the modal class here would be Republicans. Okay, and there were 19 of them. So the mode here would not be 19, it would be Republican. That's the value of the party variable. This would be a qualitative or nominal or categorical value for a qualitative or nominal or categorical variable, all right? The mode here would be Republican because it was the most frequent value for the party variable, the party qualitative variable. However, there is no mean or median here. What would be the mean or average of 19 Republicans and 16 Democrats? What, John McCain? No, you don't do that. The mode here would just be Republican. Okay, so we've talked about the mean, the median, and the mode. Next up, what if you had 20 seconds to come up with a quantitative measure for center of this data set, a measure of center or representative data value for this data set? You have 20 seconds to find it. I'll give you a hint. You might want to find two special values first. That's next time.